Firstly, we have an agent that can answer basic questions. Stop relying on standard similarity scores like good or bad score. It is the only way we can know exactly how our model works. You are completely missing the real picture. Hello, everyone. My name is Maciej Kurzawa, and I'm a machine learning engineer here at DeepSense AI. In today's presentation, I want to talk about LLM and agent evaluations. I'll discuss the things that most of us struggle with during evaluation and bring out the very uncomfortable truth about it. So let's dive deeper into what exactly I will cover today. So here is our agenda. Firstly, we'll start by defining the real evaluation problem and tell why not to treat agents like students. Then we'll walk through a practical four-step error analysis framework so that we can better understand how agents behave. Then we'll discuss the uncomfortable trade-off that comes with this approach. Next, I'll share my recommendations on how to make evaluations easier, and then I will expose some common industry anti-patterns that you absolutely need to avoid. So let's jump right into the first point, meaning let's define the problem. Usually, the development process for agent pipelines starts like this. Firstly, we have an agent that can answer basic questions. We add a few tools to improve its performance, and we evaluate it by asking a few questions and checking if the agent can use the added tools correctly. Then, if everything works well, we iterate from the beginning. And this goes until by pure accident, someone notices that the model stopped answering the basic questions we already covered in the past. So, what do we usually do? We write automated tests that in few seconds convince us that our model is definitely responding correctly about the examples that we covered before. And that is brilliant. Then we just add new tools and write more tests and add more tools. And of course, we add some more tests. And this happens until our product collides with a real use case. So when an actual end user starts using it. And why is this a problem? So I don't like thinking about evaluating agents like a school test with few multiple choice and open-ended questions. You can build tests like that for standard LLMs. However, when dealing with an agent, so it operates across many steps and uses multiple tools and modifies its environment, the evaluation must look completely different. So I like comparing agent evaluation to an escape room. The final outcome, which of course is escaping, is really important, but how the exit was found and how the tools were used along the way are crucial informations and must be part of the evaluation. And that's exactly why we need to understand the methodology of error analysis. So, what is error analysis? You can think of it as a four-step pipeline. First, we manually review a minimum of 50 full conversations, and this includes looking at the traces, meaning intermediate results, tool calls, and so on. And only this allows us to truly understand the product that we've built. Uh, the step two is open coding. This means writing down notes for each scenario, judging the outcome, and adding extra information about the sequence of events. Then, in step three, we do the so called eggshell coding, which is building a taxonomy by grouping these errors. And this allows us to crystallize exactly what our model is doing wrong. And finally, at the end, we implement fixes and iterate this whole process from scratch after every major change. So, after adding new tools or changing the architecture or uh, making some significant prompt updates. Uh, and this seems like a really straightforward framework that easily lets us iterate on errors and understand the state of our solution. However, this framework comes with a massive trade off. and I believe you already know what I am talking about. Uh, and of course, that trade-off is the time spent manually looking at traces. Uh, it is true that this takes a lot of time, but it is the only way we can know exactly how our model works and that we can trust it. In fact, it's super important to allocate dedicated time for evaluation in your project. Uh, whether it is by adding some evaluation tasks to your sprints or simply dedicating some time every day only for evaluation. Some sources uh, say that depending on the project, we should be spending up to 70% of our development time manually looking at the data. For me, and I believe in most cases, this is an overkill, but I hope you get the point. So, because this takes so much time, the important question to ask is what is the price of dedicating few hours to test a solution that will be used by many users daily? And I would say it is a very small price to pay for high standard AI reliability. And of course, it will also help with preventing costlier failures in the future. Uh, and because of that, I really like treating this evaluation time as an investment that will pay off many times over later. Uh, but of course, this still will take a lot of time, right? So maybe we can introduce some improvements to make the process easier and more efficient. And to make this human evaluation easier, we need to think about our grading model. So many of us use continuous scales like 1 to 5 Likert scale or picking continuous values from the 0 1 range. But these scales allow reviewers to hide uncertainty in middle values. It is much easier, and I highly recommend this, to choose a binary scale. It forces the evaluator into a simple decision. So, is the answer satisfactory or not? It takes significantly less time than wondering whether this response is a 3 or a 4, or maybe it's 0.7, or maybe it's 0.8. And if you are thinking about using an LLM as a judge here, try running the same test 5 or 10 times, and you will quickly see how non-deterministic and unstable the answers can be. Uh, Additionally, judges often require near perfect answers for 100% scores, uh, frequently denying full marks because they misinterpret our actual expectations. And similarly, you might receive near zero score even when your answer is clearly incorrect. So the scoring lacks proper calibration at both extremes. Uh, if you still want to use the LLM as a judge, it's important to consider the other disadvantages, such as, for example, the affinity bias. This means using the different models for the judges than the ones for generating the answers. But of course, the list goes on. So going one step back, uh, adding a binary score can be as simple as adding a thumbs up or thumbs down button under a message, and this really shortens the final time required for evaluation. To make this process even more efficient, I have two more recommendations. First, choose the annotation and observability tools really wisely. So, off the shelf platforms like, for example, LangFuse or Arrays Phoenix can be really useful, of course, but because of their complexity, using them may be an overkill for some teams, or, for example, at some stages of the development. So, if you feel like using these ready to use products is too much for your team, maybe it's better to build a custom UI, even with frameworks like Streamlit or Dash. And this will let you focus on what is actually important to you and your team, and to see the full product context without any other irrelevant distractors. And the last thing is to appoint a so called benevolent dictator. Uh, the thing is, we shouldn't have 5 engineers arguing over how to label one trait, right? So, conducting LLM eval One when conducting the LLM eval, one single domain expert should be the final decision maker on quality. And this eliminates alignment conflicts and can really speed up the process. Uh, Ideally, this person should be chosen before the first misalignment and should dedicate the most time for evaluation. Yeah, so I hope the framework starts looking promising to you right now. So once we know what to do, maybe it's time to understand what not to do. So looking at the industry, we can group the biggest evaluation mistakes into three major buckets. So the first bucket is the generic metrics tab. So we need to remember to stop relying on standard similarity scores like Rouge or Bad Score. For complex agent tasks, they are practically useless. Also, if you only evaluate the final output and ignore the underlying tool use and reasoning traces, you are completely missing the real picture. Another trap here is setting tests that quickly saturate at 90% or even higher pass rate. And when that happens, you are no longer measuring capabilities of your model, but you are chasing metric that is useless and meaningful, not meaningful. Uh, the second anti-pattern is the outsource annotation. So it might sound efficient to hand off your data labeling to a third party, but actually it's not always that good of an idea. It can definitely break the product feedback loop if you outsource before you truly understand how to control your own product. And when you outsource, your team may lose the domain knowledge about how the model actually behaves in the wild. And on top of that, you can end up dealing with inconsistency, quality thresholds across different external raters. So, firstly, it's you who need to fully understand how your solution behaves. And then, and only then, you can start outsourcing annotation. It is a good practice to, for example, set up a minimum portion of the data set for each member to annotate so that everyone have the idea of how the solution works. And finally, we have the over automation too early. So our first instinct is usually to automate everything. But we need to remember that letting an LLM do the first pass labeling on your raw traces may be a huge mistake. LLM tend to collapse highly obvious bugs into generic clusters and hide the uncertainty into middle values, as we discussed before. So basically, over automating too early only delays the hands on review of the traces. So the thing that the LLM could do for you, but inevitably will miss all the root causes of your system's failures. So to bring everything we've talked about together, here is a cheat sheet. So these are the definite do's and don'ts for building reliable AI agents. Uh, so first, do start with a manual trace analysis and get your hands dirty with the data. And when you do, adopt the binary scoring to optimize for speed and absolute clarity. Second one is choose your annotation and observability tools wisely so that they give your team the full context they need. And more importantly, choose a single benevolent dictator to make fast, decisive calls on what is good and what is bad. On the flip side, don't blindly chase eval-driven development. Stop writing complex automated checks for failures you simply imagine. Instead, target your evaluators only at the existing errors you've actually observed in your data. And finally, don't rely on generic metrics, outsource labeling as little as you can, and don't over automate your early analysis with LLMs. Ultimately, building reliable AI agents isn't about writing the most complex test suites before you even launch. It's about having the engineering discipline to look at the messy reality of how your model behaves in the wild and building your evaluations from the ground up based on that truth. The main message is Stop guessing, stop evaluating, imagine failures, start looking at your actual data. That's all for today. Thanks for watching and see you next time.